with me today. Okay, there we go. That's fine. Okay, so as far as our observational study goes, we might define an observational study as one where the researcher is merely observing and reporting the data. So a survey might be one where we are observing or where the data is coming from the individual. Observational study is simple observation and then recording. Experiment is going to be a little bit more, right? We said experiment was kind of our only way to conclusively talk about causation instead of correlation, to make a stronger claim than just these variables seem to be related in some kind of way. And so the process by which we conduct experiments is going to be much stricter than what we will see with just survey or with just this observational study. So if observational study is just observing and then recording, experiment is going to be where the researcher manipulates an independent variable while holding all others constant. And measuring, or rather in this case, and measures a dependent variable. Actually, experiment and observation can be pretty closely related. For instance, while maybe with observation, I'm not giving people earrings or taking people's earrings away or something along those lines, maybe I am, maybe for my experiment, the actual data collection piece comes from observation, right? We are ultimately looking at the dependent variable and asking the question of what is going on, and maybe the independent variable has just been something that is kind of shifted. So we can run an experiment where we do, or where the manipulations happen naturally and we just observe and get the data. But there is something very, very, very important here that fundamentally sets the experiment apart from the observation, and that is this line here. While holding everything else constant. Right. For instance, let's think back to when we were talking about independent variables, dependent variables experiments before with our correlations. Maybe we want to run an experiment that looks at the growth rates of different species of plant. So I take some kind of fern and I take some kind of ficus and I set them up next to each other and I watch as they grow. The experiment that I am running is just observation, right? I'm not like doing anything. I just made sure that the two things that I were comparing had some kind of difference that was worth comparing. And so it's not like I'm really kind of doing a manipulation. The manipulation then comes from the fact that I, as the researcher, need to make sure that the plants get watered the same amount. And I, as the researcher, need to make sure that the plants get the same amount of sun. And I, as the researcher, need to make sure that the plants are as happy as they can possibly be. that is what kind of moves this from just an observational, let's take a look at plants and see what happens, to an experiment of we are controlling everything else. We silence all other possible sources of kind of this difference in outcome, and we are observing what is a result of what we are actually analyzing, of the independent variable that we actually care about. All right, so there's a lot more control to an experiment than with an observation, and it comes from making sure that the other variables aren't shining through, that there aren't confounding variables that could mess up our results. We've already seen, or we've already talked about anyway, that this is pretty hard. An example where that we discussed in here where we kind of started getting close, but even then it didn't really quite work, was the example with the twins separated at birth, where the genetics is held constant. So genetics shouldn't be different for twins, assuming they're not for identical twins. But the environment should be very, very different. The environment should be the thing that has been adjusted between those. And so if we've held constant all of the genetic components, and we're looking at is it genetics or is it environment, then an observation of behavior would actually be akin to an experiment. That actually would be an experiment where we have held all of the other variables constant in what we are observing. But we saw that that wasn't really so clean because environment wasn't something that was so easy to control. We couldn't manipulate it as easily as we would have liked. And in fact, what we saw was that prenatal environment kind of acts as a confounding variable and messes with some of the results that we would have liked to see. So there's not quite so clear a separation between those as we would have maybe liked. Within an experimental study, we've already talked about independent variable, dependent variable. We've already defined these, independent being the thing that we're adjusting from our science definition. What do we normally use as the independent variable, just to recap? Yeah, it's normally X. It's our input. It's like the thing that we are plugging in. And then what do we normally use as the dependent, which is like what we're measuring or looking at our output for our particular experiment. That's going to be our Y. Something new that is worth talking about for this kind of experimental procedure is the experimental groups that we have to create for this. Two different types of groups. We have the treatment group, which very simply is going to be the group that gets whatever treatment we're doing, or maybe the group that is experiencing this change in the independent variable. So the group that experiences a change in the independent variable, and the control group, which is going to be kind of a group that is supposed to act as a baseline for comparison. They only are different from the treatment group in that they are not getting the treatment. Everything else about the group should be exactly the same as what we see. It should only be that the independent variable has been changed from treatment group to control group. So, importantly, the only difference from the treatment group is a lack of change to the independent variable. This also is not quite so easy to do. So we're going to talk a fair bit about various experiments that have kind of been done throughout the course of history, done well or done poorly. all that fun stuff. To start with, there is an effect that we often hear referred to in the kind of medical world that makes it pretty difficult to look at these two groups. For instance, let's say that we are running a medical trial. We're giving some patients a drug, and we want to know what effect this drug has on the health of the patients. We have our treatment group. These are the ones who are getting the drug, and we have our control group. Why would it maybe not be such a good idea to just do nothing with the control group? What effect kind of comes into play that is very, very famous and very, very kind of well spoken of if we were to only give the drug to the treatment group and then do nothing with the control group?
Placebo effect.
The placebo effect. Okay, so what is the placebo effect?
If you tell someone that like a sugar pill will work on them to help whatever, and they'll start to bleed it and it will actually help.
Yeah. So it is this really, really quite fascinatingly cool instance where a person's belief in something shapes reality. It is where this person's belief actually changes their physiology. Some really, really cool examples. So placebo effect, we could talk about specific placebo effect examples as well. I know more about the kind of the nemesis of the placebo effect. So Paxton did a fantastic job of saying placebo effect, you take a sugar pill, you believe that it's going to help you, and it actually does help you. The flip side is if you take a sugar pill and you're told that that pill might give you migraines and it might give you nausea and it might cause you to bleed from the nose and it might give you dry eyes, then you might also get those symptoms. So it works in the positive sense in that it can help you feel better. It also works in the negative sense in that it can make you feel worse. The negative component, so placebo, comes from the Latin, which is like to feel better. Nocebo, coming from the Latin noceo, which means like to cause harm, is the effect in reverse. And there's some really, really cool examples of this. One study took people who believed that they were sensitive to Wi-Fi, which is to say that they had an allergy to Wi-Fi signals. And these people were claiming, oh, when I'm around, like when I'm in cities or when I'm near like schools or Wi-Fi routers or anything, I get really nauseous, I like get headaches, things like that. And so they did an experiment where they took people who were claiming to be sensitive to Wi-Fi or to be allergic to Wi-Fi, and they sat them in a room with a Wi-Fi router. And the router would either well, there were like 4 different states of the router. The router would either be off, where its lights were off and the Wi-Fi was not being emitted. It would be partially on, where the lights were on, but the Wi-Fi wasn't being emitted. It could be partially on, where the lights were off and the Wi-Fi was being emitted. And it could be fully on, where the lights were on and the Wi-Fi was being emitted. And what the researchers found is that, in fact, they did display violent physiological allergic symptoms of migraines and vomiting and various other kind of severe allergic reaction symptoms, not to whether the box was actually emitting Wi-Fi, but to whether or not the lights on the box were on. Their belief that the box was emitting Wi-Fi was what was actually driving these symptoms. But it's not that the symptoms are fake. It's not that they're misreporting and that they think that they have a headache when they actually don't. In very severe cases, for instance, very, very kind of cool, but also not super helpful one, is with people who have asthma. The vast majority of people who believe that they have asthma do not have anything physiologically wrong with them. But belief that you are having an asthma attack can kill you. It is not helpful to tell someone who is in the middle of an asthma attack, it's probably just the nocebo effect. Let me take 5 minutes to tell you what that is. No, they need an inhaler, and taking the inhaler, while it is not physiologically correcting anything because there's nothing physiologically wrong with them, the belief that they are getting that medicine calms the attack down, and without that medicine, they can die, which is absolutely wild. The human psychology is really, 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 really crazy. And so this is a very, very, very powerful effect in medicine. A couple of different ways that we can address this. We already mentioned Paxton's example of how the placebo effect manifests is actually how we deal with it, which is through sugar pills. So if we were to take a look at a treatment group that is getting a pill and a control group that is getting nothing, we don't have a control for what's going on with the placebo effect. So what do? Well, we give one treatment group the actual drug, and we give another group, the control group, a sugar pill. This is to, again, kind of deal with any effects that we might see, any positive or negative effects that we might see coming from the belief that they are taking a drug that is going to be made helpful. Now, would this work if we were to tell the people who are getting a sugar pill, you're just getting a sugar pill, you shouldn't experience any kind of side effects, this shouldn't help you at all? Would that act as a way to control the variable that is the placebo effect, if we tell them that they're taking a sugar pill? No, right? The placebo effect comes from the belief that they're taking real medicine, and so that wouldn't do anything. So how do we have to conduct this? When we are assigning people to either treatment group or control group, what do we have to do to make sure that this goes well? We have to tell everyone that they're getting the same thing. Sure, we could probably lie to them and tell them that they're all getting a sugar pill. That would probably work. But we could also lie to the ones that are getting the sugar pill. Generally, this is how it's done, and tell them that instead they are getting the treatment pill, right? When we do this, when we lie to our people that we are doing, medical studies on, which is super commonplace, it's part of, you have to do it. This is called a blind study because the people who are being studied are blind to whether they are in the control group or the treatment group. So that knowledge doesn't influence kind of what they see in terms of behavior. Also part of medical studies, which is another kind of funny one that comes up in a somewhat surprising way, is that it is possible for a doctor who is administering a pill that they know is a sugar pill to treat that patient differently than if they are administering something that is a drug. Behavioral changes could just be as simple as paying more attention to the patient who they know is taking the drug, and or maybe being dismissive of some of the symptoms that are being described by the patient taking the sugar pill. What would we need to do to ensure that the doctor's behavior towards these patients is also a non-issue for this? Don't tell the doctor which pill is which. And so you end up with what are called these double-blind studies, where the people who are distributing the pills have no idea which pill is which, and the people who are taking the pills have no idea which pill is which. And in doing so, we successfully control for the confounding variable that could be the placebo effect. Not that the placebo effect is gone, just that we would expect it to affect both groups the same way. And so what we would then compare is the difference between those groups in order to kind of tease apart what the drug is actually doing. So you might expect the placebo effect and the nocebo effect to produce some kind of effect, but we would expect that to be weaker in the control group if the drug is actually doing what it's supposed to do. All right, questions about our kind of medical study setups? So placebo effect, nocebo effect, this is like physiology. It's like the actual like state of the body. There is something that is very similar to the placebo effect that is a little bit more psychological, a little bit more behavioral, and that is called the Hawthorne effect. Essentially, the idea of the Hawthorne effect, very, very similar to the placebo effect. Being a part of an experiment might influence your behavior within that experiment. So knowing the goals of an experiment can influence the behavior under study. All right, similar idea to the placebo effect. How do we deal with this? What do we have to do to not have to worry about telling someone, hey, we're going to be measuring to see how good you are at identifying the color blue, and then having them be really, really focused on identifying the color blue? How do we bypass this? Don't tell them, or lie to them about what you're actually studying. Right? You lead them in one direction when in fact you're studying a different variable. The kind of mid to late 1900s, really, really fun time period to pull some very heinous experiments from that would definitely not be allowed to be conducted today. Very famous example of where we see this kind of attempt to combat the Hawthorne effect in a fairly kind of obvious way. There's an experiment done where they had individuals come in and under the supervision of a test administrator, they were to deliver electric shocks to people who were answering questions incorrectly. That is what they were told. They were told, hey, we are testing this other person. What we are trying to study is how people test under a stressful situation. Right? In fact, there was no one taking a test. There was no one getting shocked. But the person who was administering the shocks, who was being told to administer the shocks, believed that there was. The actual test was how far are people willing to go when someone in a position of authority is telling them to do something that would go against their normal moral imperatives. This is kind of in the wave of the like post-World War II attempts to like rationalize or understand how something like the Holocaust could happen. How could you have all of these people doing something so absolutely atrocious? This and like the Stanford Prison Experiment, and the idea that this one really did kind of convincingly show was that when you have a figure of authority telling you to do something, you are a lot more likely to go a lot further than if it were your own kind of judgment call to make those decisions. Which very, very fascinating. And if they had known, hey, we're trying to figure out how much of a sheep you are, with these electric shocks, then that would obviously very drastically sway the results of the study. You wouldn't be able to do that and get results that you could use. All right. So kind of prevalent throughout all of this is the idea that a lot of what we are doing experimentally is trying to kind of combat the possibility of having confounding variables. We've already talked about what confounding variables are. Murders not causing ice cream rates. There might be something else that's going on. The idea here, though, is if we do our study well, we shouldn't have to worry about confounding variables. If we properly control everything that could be affecting what is going on, our particular output, then confounding variables shouldn't be an issue. And because confounding variables are not an issue, rather than claiming correlation, what do we get to claim? Causation instead. Very good. So all I want to add here is that proper experiment gets to basically ignore confounding variables, not because we're actually ignoring confounding variables, but because we've already dealt with them. We've already addressed them. They can't be what's causing the change in this because we controlled for it. We silenced that variable. Yeah, exactly. Killed the variable. Yeah. Now, as far as the strength of our result, to this little blurb at the end, when are observational studies better than experimental studies are always going to be stronger than observational. They can't be worse than observational. But there are some limits to what we should probably be allowed to do for an experiment. For instance, if I wanted to conclusively show that ice cream, that murder rates don't cause an increase in ice cream sales, where the murder rates is my X value, I probably shouldn't run that experiment where I check to see if killing more people makes people more hungry for ice cream. Probably not an experiment that we want to run, or maybe whether we want to or not, probably not an experiment we should run. Probably best to just leave that to observation. Again, maybe in the 1970s or 1980s we could run this. Probably not by today's standards. You would not get board approval for this. So ethical constraints to experiment are areas in which you kind of have to rely on observation, which is good. We're happy with that. We're okay with that. Okay, so take a moment to read through the study. We'll take 2 minutes or so to read over this, and then we'll go over some of these questions here, talking about this particular study. All right. Go ahead and get started here. So a couple of lowball questions to start, but actually I say that definitely worth addressing here. What type of study has been described here? Experimental, okay. Beyond the fact that the first line says that a company conducts an experiment, what here is really cluing us in to the fact that this is experimental rather than observational? The placebo is really, really important to this. So remember, the key difference between experimental and observational: experimental is attempting to control other variables. The administration of a placebo pill is the attempt to control other variables. So this is this line right here is actually what clues us into the fact that this is a well-done experiment. All right, we're controlling For the placebo effect, we're controlling other variables. So I absolutely agree. This is experimental. All right, what is our independent variable? What kind of, what's being changed? What are we controlling as the researchers?
The pills.
Yeah, the type of pill, sugar pill or medication. And what is our dependent variable? White blood cell count. All right. And which group would be the treatment group? Yeah, the ones that got the medicine. Okay. So number 4, here's where stuff gets maybe a little sticky. Could the white blood cell count be affected by knowing that they are part of the study? So in other words, would we necessarily have to worry about the Hawthorne effect for this particular measure? I would probably lean no. The one thing that gives me pause for definitely saying that there's no way would be the idea that maybe stress can affect white blood cell count. I think that's true. Like being stressed hurts your immune system, and white blood cells are part of your immune system. So I could actually, like if someone told me that that was the reality and it's because of the stress, I would not be horribly surprised. More important than that, do we care whether the Hawthorne effect is in play here? Or is our experiment set up in such a way that it shouldn't really matter? It shouldn't really matter. Again, why? It's similar to what I've asked before, but why, even if the Hawthorne effect, even if knowing that they are part of the experiment is changing this measurement in some way, why should that not really affect our results? Which group or groups would be affected by the Hawthorne effect, assuming everyone's been told the exact same thing? So the one that got the real pill, and then would stress be affecting the ones who got the fake pill but who thought they were taking the real pill? Yeah, probably that would affect them as well. So this Hawthorne effect isn't something that's just going to target the treatment group and mess up our experiment. It's going to target the treatment group and the control group equally. And so it might affect the numbers, but is it going to affect the difference in the numbers between the two groups? Probably not in a substantial way, or hopefully not in a substantial way. So I would say here that probably not. We probably wouldn't see this kind of change. But even if we did, it wouldn't matter either way because it should affect both groups equally, or at least relatively equally. We wouldn't expect taking the real pill while thinking that you're taking the real pill and taking the fake pill while thinking you're taking the real pill to produce different amounts of stress in our groups. Right? That'd be a little weird. That would be a little bit weird. Okay. If blood pressure was used instead of white blood cell count, could the blood pressure be affected by, again, this Hawthorne effect? Probably, right? Again, in this idea of like being stressed might raise your blood pressure. That could certainly be possible. Would it matter? Would it matter to our experiment? Are the groups being affected differently by this knowledge, or would the effect be the same in terms of averages across both groups? You'd expect this to be the same, right? If we are telling these people that, you know, they're part of an experiment and that's what's influencing their blood pressure, then as long as we give that information to both groups should be affected the same way. As long as we make sure that the only difference between the groups is the actual pill that they're taking, we should isolate everything else, right? So here I would say probably the Hawthorne effect probably does affect the numbers. But again, it still doesn't matter. Because both groups are affected similarly. It's tricky here. It's like, again, it's not, we haven't stopped the placebo effect by giving them a placebo pill, right? Both groups will still experience the placebo effect. Both groups think that they are taking medicine and that thought will improve them or cause side effects in the case of the nocebo effect. We haven't stopped the placebo effect, but we haven't made it a variable. It's not a difference between the two groups. It is constant between both groups. Likewise, we can't stop the Hawthorne effect. That's not our goal. Our goal here is not to diminish or stop the Hawthorne effect. We're just trying to make it so that the Hawthorne effect is affecting both groups in the same way, so that it is a constant rather than a variable. So, a little bit tricky there, but just kind of thinking like, what is the difference between these two groups? If it's just the treatment, then we're probably good, even if there are things that are changing what the numbers actually say. Okay. Beyond placebo and Hawthorne, what are maybe some things that might, outside of, you know, taking the sugar pill versus taking the medication, that might affect someone's blood pressure or white blood cell count? Yeah, maybe someone who's sick has like a lower or higher white blood cell count, probably depending on where they are in the illness. So maybe we chalk that up to like individual differences between the people being studied. I think being sick is a very good one. We could also maybe see like maybe just different immune responses, genetics, or maybe different immune responses depending on like how healthy they are, things like that. There's going to be a little bit of individual difference between what we see there. Main way that we're going to combat that, that's actually an issue. And if our sample size is particularly small, those individual differences become larger. They become a lot louder. And so a way that we could combat that is rather than conducting this experiment with 25 people in each group, we do it with 250 people in each group. Or maybe we do this experiment with 25 people in each group, but we do it 100 times to just make sure that we're not seeing something weird because we just picked a group of 25 weirdos who just have a weird response to this particular pill for whatever reason. We just happened to pick 25 people who all have a super rare disease that affects how they react to this particular drug. Unlucky us. So we do it again and again and again and again. What else could maybe affect how a medication affects someone? What could alter that? Yeah, so maybe allergies. I would chalk that up probably to the individual differences as well, like a person being allergic versus not being allergic. And again, that's why we need to sample a whole bunch. I like that idea, though. I think that one's good. So allergies, whether they're sick, those are good. What if they're what's something that you have to check off when you're at the doctor's office before they prescribe you medication? There's like a very important piece of information you need to tell the doctor before they know what meds to give you. Yes, which again would be like individual differences.
Okay. Up here. How old you are?
Possible again, yeah. I think all of those you would certainly expect to see things. I've kind of given a really big catch-all here is the problem, right? All of those are perfectly valid, and the way I wrote it is kind of just acting as like a sink for all of them. But all of them, great, totally correct. Yeah, which I'll throw under there as well. That's fair. Yeah. I would say one that they would probably need to screen out ahead of time would be if they are taking any other medications. Right? Not necessarily like an individual differences, but like, you know, a person who's on Advil might react differently with this, or a person who's taking Tamiflu might react differently, or what have you. And so generally you would have to do a disclaimer that's like, I'm not on any drugs, and so I'm not particularly worried about this. All right, questions with our experimental procedure setup, questions with our observational study, things like that. Okay. So we're going to move on to 2.4 momentarily. I am going to give you guys a 5-minute kind of respite, stretch, move around, whatever you got to do. 2 people at a time. Once the hall passes are back, this would be a good time to use the bathroom if you need to. If you have any questions about the classwork that you want to ask, now would be a really good time to do so. But just take a moment to breathe in between now and what we're going to do for frequency distributions. Yeah.
Classroom late, like if it's late, and we make up 275, does that mean that like it goes down every day, or like if we get 100 on it, then we get 75 in the
Yeah, exactly. Okay. Yeah. Yeah.
Where's the classwork at?
It's on the MyMathLab. Yeah. So if you type into, it's not on ClassLink. You have to type into the search bar MyMathLab. The chapter 2, all the unit 2 stuff is due for before the unit 2 test, which is February 6th. But if you have finished the 2.1 and the 2.2 by the quiz that we have on Monday, so Monday like Monday by the quiz, then you'll get bonus points on the quiz.
I have the chapter 1. I missed
Okay, do you have the homework?
I missed the test, so
Yeah.
yeah. I can take that next one.
Okay. Well, we can figure out a time next week.
It's crazy.
I'm not done with this.
It's all just like Christian. We made a little stop motion animation, but it's like it's like at a certain and they believe that the modern points show. They believe the Generation 4 version should have stayed out for.
Are you serious?
14 seasons. It's like, yeah, information every few years, and there's a cartoon. It's a generation. Christian. That's all. It was Generation 4. And it ended, and Christian was like, no, like, he said, I prophesized that it was going for 15 seasons. So go ahead and make those. And like every now and again, just go on Twitter. It's feeling. Wasn't that your last more seasons? Yeah. It was the
nothing makes me feel like more out of shape than the first 2 days back in school where my legs yeah.
It's terrible.
What is
the going classes in middle school? We had like 2 lessons to go, and you just have to like pretend that you're not a breath the entire time.
So my freshman year of college, I was in the, we had like themed dorms, and I was in the sustainability dorm, where you got shamed if you took the elevator. And I lived on the 5th floor of the sustainability dorm and had to walk up and down 5 flights of stairs at least like 4 times a day to get to and from like classes. Yeah. Shit. I only went up the elevator once. The whole year. It was quite something. But no, the amount of walking that I do while lunching is like this is nice in that like because my setup is over here, I get to sit down. But like every other class, I'm like pacing back and forth up here, and it is a lot. Not as bad as when I was doing the white class stuff, where I was like, I would finish on this and then I'd be over here.
I love doing activities.
All right. So let's take a look at our 2.4. You'll notice that in the packet that you guys have, there are 2.3 notes. 2.3 is just like how to enter things into your calculator. There isn't anything to like fill out there. It is all filled out for you. It's just like a step sheet of how to access certain things in your calculator. A lot of this is stuff we already know, like how to do the list stuff. There's the one variable stats option and the calculate feature that we'll need for next chapter. So that is something that you guys have access to. I am not going to teach to it because it's just like a list of buttons to press. And so if you need to press those buttons, then those are there. And I'll probably go over it as we need to when we need to for chapter 3. So 2.1 is a lot about like types of data. 2.2 is a lot of how to properly collect the data. 2.4 is going to be ways in which we can organize the data so that we can start, interpreting the data next. All right, so very, very kind of systematic. We now know what the data is. We now know how to do a good sample. We now know how to run a proper experiment. Now it's just a matter of how do we present what we have actually been able to find. And we're going to start with we're going to see there are a bunch of different ways that we can present this. And I would say that really there isn't, we'll talk about advantages and disadvantages to them as they go. They're pretty synonymous. We're going to be starting with very, very basic, what are called frequency distributions. So we've already talked about statistics as being like the tools through which we are going to analyze our data. A frequency distribution is going to be, just to make sure I'm giving you good definitions, the way that we organize the data that we have collected. All right, so we run our sample, we run our experiment, whatever, we get a bunch of data. We're going to put that data into a frequency distribution. 2 important characteristics. This is all like one variable data. So scatter plot was 2 variable. This is all just like a single variable that we are analyzing here. There is what is known as the class for a particular variable. The class is going to be a class is going to be a possible value that we could see for our variable. And all of the classes, like the holistic list of classes, would be every possible value that we could see for our variable. So this is a particular value that we could see for our variable. Now, when we use the word value, we probably default to thinking that this is going to be referring to a number. Certainly it can refer to a number. I'm using value in more of like a computer science sense, where like taking on a value is just like being represented as one shade of the possible different variables I can get. So for instance, we looked at the Tetris piece example. It is possible that I could get a frequency distribution for the variable that is the color of the pieces. Maybe we're playing a weird version of Tetris where 4 of the 20 possible variations of pieces that we could get are yellow. And so yellow would be one of the classes for my frequency distribution. Yellow, blue, red, the buckets that I could see. Now, it could also be a number. It could actually be a value. For instance, if I am looking at maybe the class is like my actual classes, and the thing that I am measuring is number of sweatshirts. Maybe one class has 11 people wearing a sweatshirt, and then my other 2 classes have 14 people wearing sweatshirts. Then those classes, those periods, the like things that I am actually, no, the classes are the sample. Sorry, classes are the sample, and then the number of sweatshirts would be the what we're talking about here, the category, the bucket that I could fit into. All right. The frequency for a particular outcome is going to be the number of times we measure a specific class. So in my sweatshirt example, where one of my classes has, I measured 11 sweatshirts, and in 2 of them, I measured 14 sweatshirts. My classes of my frequency distribution are either 11 or 14 for number of sweatshirts. I have a frequency of 1 for 11. Only one of my kind of things that things that I analyzed gave me an output of 11, and I would have a frequency of 2 for that class of 14. Might be a little bit easier to see if we start categorically, though. So in this case, we are taking a look at a qualitative variable that has been analyzed and put into a frequency distribution. In this case, people were asked about their preferred car manufacturers. We asked 40 different people what their preferred car manufacturer was, and we saw this particular outcome. Notice that the classes are the possible answers that we could have gotten to our question. It's the possible values that we could have seen for our variable. People could say Ford or Audi or Volvo or Honda or whatever. Right? So that's the class. It's what the variable could be. And the frequency is the number of times we see a particular answer. Right? So of the 40 people that we asked, 13 of them told us Ford. That tells us that the frequency of Ford would be 13. On its own, frequency is not very helpful. 13 could be a really big frequency, or it could be a really small frequency. It depends on the number of people we ask. Right? If I ask 15 people and 13 of them say Ford, that's a really, really overwhelmingly large frequency. If I ask 10,000 people and 15 say Ford, that communicates something very, very different. So frequency alone is generally not the important value that you're going to see here. Instead, what is represented most commonly is what is called the relative frequency, which is essentially converting our frequency into a percentage. All right, so the frequency of the number of people who said Ford was 13. That's cool, but a much more useful metric is to say that 13 out of 40 people answered Ford, which, plug it into your calculator, multiply it by 100, tells us that 32.5% of people prefer Fords. Which is much more useful, right? That's a much more useful heuristic than just saying that 13 people of all of the ones that we measured liked Ford. This gives us a context for, is that number a lot or is that number a little, which is just more useful. All right, questions with our qualitative or categorical frequency distributions? You feel good about like what I mean when I say a particular class? You feel good about the difference between frequency and relative frequency? So a particular class would be like one of these manufacturers, and then all of them are like the list of all classes. So again, just to clarify. So that's qualitative, pretty straightforward. Quantitative, we generally use something that is called a grouped frequency distribution. So this is used more for quantitative information. And the reason why is actually pretty straightforward. For instance, we do a measurement, we collect this data, we get all of these ages. Cool. We could treat each of these possible values for our variable as its own class. We could do that and run our frequency distribution. That table is going to be enormous, right? We have like 50, I think, different ages here. Most of them are really only showing up once or twice. We're going to get a lot of frequencies of one, and our table is going to be incredibly, incredibly, incredibly tall. That's not a very way to collect this data. Right? So it's not that we couldn't do it, it's just that the visual would kind of suck. It wouldn't be great. Generally speaking, then, the way that we are going to deal with quantitative info, rather than treating each possible value as its own class, we instead establish a particular class limit, which is a range of possible values that could fit into a particular class. So for this data, we might arrange it as we see here. Notice that for our class limit, it's not a particular value of our variable, it's a set of values that fall within a range. So for instance, if we measured the variable and got a 57, then we would know that we need to put it with this class. Or if we measured our variable and got a 75, we would know that it needs to go in this class. So class limit versus class limit is just giving you an interval, and that's just kind of a more convenient way to group this information when otherwise we would have just a massive list and the tallies would be very, very lackluster. All right, within a particular class limit, so within a particular interval here, we can talk about like the upper bound of the class limit versus the lower bound of the class limit. So for instance, if I'm looking at the class from 56 to 62, what would we guess is the upper class limit? 62. And what would the lower class limit be? 56. So the upper class limit is like the largest value in a class limit, and the lower class limit is the smallest or the lowest value in a class limit. Also really important to this, kind of more important, I would say, than the whole upper versus lower, is the class width. What do we notice about the size of each of our intervals for this particular set of class limits?
6.
So they're all, we're going to put an asterisk on there. It looks like they're all 6. They're all the same, though, is kind of the important thing here. Is that the width is constant. So our class width needs to be uniform. Here is a fantastic place where someone who knows about statistics and is trying to lie to you could mess around with a table to adjust the way their findings look. They could mess with the widths. Maybe their graph makes it look like maybe they collect a bunch of data from people who are like 30 to 50, and then they look at people who are 51 to 53, and then people who are 54 to 56. And what we see in the graph is, oh, there's a huge amount of data here, and then not that much here, and then less here, and then less here. And it's because they're messing with the widths, not because there's actually a significant difference between demographics. All right. So this uniformity of our kind of class limits here is really, really important. Now, Nathan said that they are all 6. It looks like they are. But do you guys know how, like, when you're trying to figure out the number of days, like if you're given 2 dates and you need to figure out like the number of days, like if I said January 22nd to January 26th, it feels like that would be 4 days. But actually it's 5 days because we have to count where we started as like day 1. This is going to be a very similar issue where it's going to be very tempting to look at this, and I did the same thing. I looked at this and I was like, oh, the class width is just going to be 6. But in fact, we have to adjust for the fact that 35 counts as like the first value that we could possibly be. And so what would the class width here actually be? It would be 7. We just take that like subtraction and we just add 1 to it. So class width would be 7, and you can just count, right? 35, 36, 37, 38, 39, 40, 41 would give us 7, right? But it is counterintuitive, and this is a place where a lot of people are going to mess up. Mark my words now, hearing me, I'm telling you where on the test you're going to mess up. This is where, all right? So don't make that mistake. If you need to count it out, count it out. There's no shame in that. That's what I did. But it's like days of the week where you have to count. You're not starting at 0, you're starting at 1, so it increases your count by 1. All right. What is the relative frequency for the, let's go ahead and knock this out, relative frequency for the class limit of 59 to 55? How would I construct this? Yeah. For, what do I do with the 4? Out of 50, and then how do I turn that into a percentage? Times 100, and so we get that this is 8%. Out of 50, it's kind of nice. You can just double the numerator, double the denominator, and you get out of 100. Not too bad. Okay, the only other thing, last thing that we are going to address super, super quickly, technically speaking, we could have whole number class limits like this, but still get decimal answers. This one feels very, very intuitive, but I am going to mention it here. The class boundary accounts for values that we might see that might not necessarily be covered explicitly within a particular class list. The only thing to note really with class boundaries is that we are going to follow our rounding rules to fit to the class limits. So for instance, if we get 34.6, that goes in our first class because it rounds up to 35. If we got 76.4, that would go in our 70 to 76 class limit because it rounds down to 76. So follow the rounding rules to the nearest, whatever the data is being measured in. If we measure the data in tenths, you would round to the nearest tenth. If we measured in hundredths, you would round to the nearest hundredth and then sort accordingly. Pretty straightforward, hopefully. All right, questions here on either any of the experiment stuff that we've done or this kind of start of the frequency distribution stuff. Okay, I want to mention a couple of things that I want to mention really quickly, and then I'm going to give you guys some time to work on your classworks. First, I wanted to address something on the test that I messed up, and I've already gone back and reimbursed everyone. Your grade is updated, has been updated, not a change, but it is something that I wanted to kind of talk about, that I wanted to address. At the end of the Unit 1 test review, that very last question, I said that if you get a linear coefficient r equals 0, that it means that you have no correlation. I said that that's true. That is not true. That is false. Why is that false? Why is that not necessarily the case? So a linear r value of 0, I'm saying that that does not necessarily mean that we have no correlation. Why would that be?
Because the closer to 0, like the more scrambled it is, right?
So being close to 0 does move us towards being no correlation, right? So r of 0 we do interpret as no correlation. But what's the issue here then? Because that was the mistake I made, was saying like, oh, r equals 0. Yeah, definitely. There's something very specific. There's something very, very specific. Well, it's fine to get 0. We can see an r of 0, and sometimes it does mean no correlation whatsoever. When might we get an r of 0, but it doesn't mean no correlation whatsoever?
There's only 1 point.
Well, so having less points, 1 point, 2 points, that would give us like an r of 1. So that would give us like way too strong. What do we notice about the scatter plot that's on the board here, the one in green? It's a parabola. What would the linear value of r probably be for this particular scatter plot? Well, not necessarily asymptote. Well, like, what is a line? Is there a line that fits this well? No, there's not a line that fits this well. The linear r value probably sucks. It probably does tell us, hey, this isn't a line. But if I ran a quadratic regression, I'm probably going to get a really strong r value. So the problem here is that you can have nonlinear correlations, and that's okay. So less an issue with our interpretation of what r equals 0 means, and more just the idea of, if we get a linear regression that says that r is 0, we have to check all the other regressions as well. If every regression we do says r equals 0, then there's definitely no correlation, but we would have to check a bunch of different regressions in order to actually see. Okay, so just wanted to clarify that. Next week, so Monday, you guys have the 2122 quiz. The classworks, 2122 classworks. If finished by that point, you get the extra credit, same deal as with the last quiz. I am not going to be here on Monday or Tuesday. So I'm going to leave the sub with instructions for the quiz. It should be easy. It'll be open for you guys on Schoology. But for after the quiz, I will have a recorded lecture finishing 2-4 for Monday, and then finishing 2-5 for Tuesday. Once you're done with the quiz, go ahead and watch those. If you finish all that early, you can work on the classworks. 2-4 is already open, and I'll get the 2-5 posted. If you have any questions, feel free to reach out, although I might be a little bit slow to respond for that. All right, and you guys have the rest of this time to work on classwork, ask questions, whatever you need to do. Yeah. Yeah, basically it's like multiple choice. It's all vocab stuff. It should be pretty straightforward.